Good morning, sir. Today I am presenting our Pocket CubeSAT development project. This project is conducted under MacroEdtech, where we design, develop a functional CubeSAT prototype. My name is Akshata Sigi. I am an electronic engineer and the project manager of this project is Sagar Sakri. The actual goal of this project is to simulate the complete small satellite engineering workflow. As here is the objective where the MacroEdtech will design, develop, integrate the functional pocket CubeSat prototype that simulate real small satellite engineering. So in this there is a project we will gain practical experience in embedded systems, telemetry, communications, power systems and satellite subsystem integration. So here is the project objective. So what we can say that the main objective of this project is to design, develop a functional pocket CubeSat prototype. This prototype simulates the real satellite operations such as embedded system, control, telemetry, communication, onboard data logging, power management, ground station monitoring. The success of the project is determined by the several criteria. Then here comes the step, that is the first important step. We will go with the environmental data must be successfully transmitted using LoRa communication. Second, the data must be stored in the macro SG data logging module. Okay, so then we will go with the part of CubeSat which must maintain stable battery operation. Then we will be going with the ground station which should be display real time telemetry data. Then the final part of the project must be we will be delivering complete documentation and the working demonstration system. Okay, so project scope. So on this we will be understanding the project scope, focusing on building an educational CubeSat prototype using commercial off the shelf component. The main subsystem is the onboard computer which can be implemented using Arduino or STM32 microcontroller. In this, the environmental data is actually collected using BMP280 sensors which measures temperature and atmospheric pressure. The collected mission data is stored locally using a micro SD data logging module. Okay, so in this all subsystems and those are all integrated through the custom printed circuit board PCB that is designed using KiCAD software. Okay, additionally we have also been using a Python based ground station software in developed to monitor elementary data and control the system. The project mainly includes we can say that is the system integration, testing and full technical documentation. The next come over here is the project deliverables. That is the MacroEdtech will provide the following key deliverables to ensure the successful CubeSat design and develop and validation. Okay, so here are some steps that we are going to cover up. Those are all. The first comes system architecture and the project and the block diagram which show the overall structure of the CubeSat subsystem. The second is the bill of the material which lists all the electronic and mechanical components required for the project. Then it comes with the circuit schematics and the PCB design files which are prepared using KiCAD for the fabrication. Then the fourth comes, that is the firmware source code which is maintained in GitHub repository for the version control and the collaboration. A Python based ground station software is developed to receive telemetry data and send commands, which comes at the fifth part. Then we will be having the project including fully assembled CubeSAT prototype. Then we will be having the testing and validation report that are prepared to analyze performance and the reliability. In the end of the project, that is the final part, the project provides the complete technical documentation including design, methodology, system operation and the future improvements. Okay. Okay, here are some project phases. The CubeSAT development timeline, as we can say. This ensures the organized development and efficient project management. The phases are here. There's the first phase comes the planning. The basic part is where mission required and system architecture are defined. Okay, we will go with the first part of planning. Then the phase 2 come, that is the design, where circuit schematics, firmware architecture and PCB layouts are developed. Then the phase 3, that is procurement, where electronics components are ordered and PCB manufacturing is arranged. Then we will have the fourth phase, that is the development, where sensors, communication systems, power subsystems are individually tested. The phase is integration, where all the subsystems are assembled into the CubeSat prototype. The final phase is validation and delivery, where the subsystems are tested, documented and prepared for the final demonstration. As these phases approach, ensure organized development, which is a risk reduction and the timely delivery of fully functional CubeSat prototype ready for the demonstration as well as evaluation. The sixth slide overcomes here, that is the perfect weekly timeline. Okay, so what we are going to do in week 1 and 2 and 3, 4 and 5 and 6. Okay, so here comes the planning and requirement for the week 1. The project planning and requirement analyzes the whether the project is completed, like we are going with the correct assigned roles and create the project roadmap as we are going to work with for the weeks. In week 2, the system architecture block diagrams and component selection are finalized as for approved design files and component list. So here comes with the third week, that is PCB development and the component ordering. We are going to go with the PCB layout, which is designed in the component and ordered well. PCB files ready for manufacturing and order components, as it is said here. In the week 4, subsystem development, developed individual subsystem power. Okay, so the communication modules onboard computer are developed and then tested, and it has been checked working subsystems prototype. Okay, so here comes with the week 5, that is an integration part, where we are going to have the assemble CubeSat structure, then debug hardware and software integrations. All the subsystems are integrated into a complete CubeSat unit. Okay, fully integrated CubeSat prototype. Then we will have the final week, that is sixth week. The system undergoes testing, validation and then a perfect documentation preparation. Will prepare testing reports and final technical documentation, create presentation materials. Then the output that we will be getting is tested CubeSat prototype with the complete documentation. This structured timeline ensures the perfect and systematic development and timely completion of the project. So here we will be concluding the presentation, and here I will be covering the conclusion part, that is the project CubeSat development project provides a practical platform for learning real satellite engineering concepts. The project integrates multiple technologies including embedded systems, wireless communication, PCB design, and ground station monitoring. By following a structured development process, we are able to design, build, test functional CubeSAT prototype. This project not only demonstrates the end-to-end CubeSat development workflow, but it also enhances the practical engineering skills. So in this overall project, there is successfully delivers a low-cost educational satellite prototype along with the complete documentation, making it a valuable learning platform for future satellite development. Thank you. Thank you for your time, and I would be happy to answer any questions regarding the CubeSat development project.